Welcome to Algebra with Jennifer. We're going to take a look at the standard form of a quadratic function today, and we're going to learn the steps to graph it without using a calculator. This is the standard form right here, ax squared plus bx plus c. When we're graphing, and this is going to be the example that we're using, when we're graphing, the very first thing we want to do is identify what the a, b, and c values are, because we're going to use these for different aspects of the graph. So I take a look at my example here, and I remember our a is what's in front of the coefficient of the x squared. The b is the coefficient of the x, and then the c is the constant number at the end. So when I look at my example here, I've got a positive 2 for my a, a negative 4 for the b, and a positive 1 for the c. Of course, you don't have to write positive, but I am just for this first example here. Okay, so now I want to take a look to say, okay, what's the general shape of this graph? Because when I go to graph it, the shape has to match. It's an easy way to tell if you've made a mistake. If it's concave up, but your graph is concave down, you know, wait, I made a mistake. So we're going to look at the a value to see the shape of the graph, whether it's concave up or concave down. So if the a is positive, the graph is concave up, which is like this. If the a is negative, the graph is concave down, which is like this. Okay? So this graph is concave up because the a is positive. Right? We have a positive 2 for our a value. Now let's take a look at whether we have a vertical stretch or shrink. We're going to use the a value to see if there's a vertical stretch or shrink. So now again, we're looking at the a value. If the a is greater than 1, the graph has a vertical stretch. That means it gets more narrow. It gets pulled. The y values have doubled or tripled. If the a is between 0 and 1, in other words, 1/2, 1/4, 1/3, the graph has a vertical shrink. That would be, it's wider. So again, as we're graphing this, we're making sure the features of the graph match. This graph has a vertical stretch because the a is 2, which is greater than 1. All right, let's continue our example. Now we're going to take a look at the axis of symmetry and the vertex. We're going to take a look at these two things here. We're now on to the b value. The b value, as you recall in our example, is negative 4. So we're going to use the b value to find the axis of symmetry, line of symmetry, and then we're going to use that value to find the vertex. So to find the axis of symmetry, we have this little equation that we're going to use. On my little example right here, I can see that this line of symmetry or axis of symmetry is what splits the graph in two. On the left side is exactly the same as on the right side. They're symmetrical. That's what we're going to look for today. Notice this says x equals. It's going to say x equals some number. In this little example, my line of symmetry would be x equals 1. So it's this line that goes right down the middle of the graph. We're going to then use this value of the x to replace it to find the value, the y value of the vertex. So let's give this a whirl. So my equation here says the opposite of b divided by 2a. Well, the opposite of b, right now my b value is -4. So if I had the opposite of -4, that's really +4, correct? Over 2 times a, and remember our a value is 2. So the opposite of -4 is +4. 2 times 2 is 4, so this equals 1. So my axis of symmetry is x equals 1, which is actually just like my example. So I know the vertex, I know the x value of the vertex is 1, right? Because it shares the value with the vertex, because the vertex sits on the axis of symmetry. But we need to now find the y value. So let's do that. I'm going to now insert 1 as my x value, and we're going to see what the y value is. All right, now let's go ahead and solve this. So 2 times 1 is 2. 1 squared is 1. 1 times 2 is 2. Minus 4 plus 1. So as you can see here, my y value is -1. So I now know the vertex. The last thing I need to find is the y-intercept, and I find the y-intercept by looking at the c value. As you recall, our c value is that constant down at the end, which is 1, which means my y-intercept, the x value, is always 0 on the y-axis, and the y-intercept is at 1. Lastly, we're going to graph this parabola, and I'm going to use all of the information that I just found out. Let's review. I know that I'm going to have a graph that's concave up, so it's going to be an upward shaped U. I know that there is a vertical stretch of 2, so I'm going to have a skinnier, taller and skinnier graph because my y values will double. I know that I have an axis of symmetry at 1. My vertex is at 1, -1, and I have a y-intercept at 0, 1. So let's put it all together. I'm going to go ahead and start with my axis of symmetry. I'm going to just draw this imaginary line here. The vertex is at 1, -1, so I'm going to give myself a distinct point there. I know the y-intercept is at 0, 1. Now I can see this upward shaped U starting to form. Next up, I'm going to reflect this point across, because remember the axis of symmetry, it's the same on both sides. Well, you look at that, you can really see that vertical stretch, right? The parent would have landed right here, out 1, up 1. This guy is out 1, up 2, which is our vertical stretch of 2. So you can see that vertical stretch. What else do we have? I would like to try to get 2 more points. Let's see if we can. If you recall, the parent function would have gone out 1, up 1, out 2, up 4, 1, 2, 3, 4. That's what our parent would have done. But my y values doubled. I'm going to do times 2 on those y values. So instead of out 2, up 4, I'm going to go out 2, up 8. 5, 6, 7, 8. Look at that. I can just squeeze it on there. Boom, and then I'm going to reflect it. 1, 2, 1, 2, and there's my graph. Try to draw a nice U shape here. Look at that, didn't even use a graphing calculator. Last up, I have domain and range. It's always nice to keep that in our thoughts. My domain for this graph. Remember, domain are your possible x values, and since we have arrows on both sides, we're going to have from -infinity to +infinity. Range are your y values. The lowest y value is your y value of your vertex, which is -1. And we're cruising on up to +infinity. I hope this helped.